Investigate horizontal transformation. Now we are taking up some examples with reciprocal function, and I will suggest the best way of sketching these graphs. So what we need to do here is describe the transformation and sketch the graph of each transformed function. So I have two of them here. So when you see reciprocal function, or for that matter any other function which is being transformed and you need to sketch a graph, first thing which you have to note is what is the coefficient of x. Now as we see in these examples, coefficient of x is 2 in the first example and coefficient of x is -1. So if coefficient of x is not 1 but any other thing, maybe even -1, we should always factor it. So first step is factor this and rewrite your function. So this now should be written as 1 over, take -1 outside, so minus that means, right? And when you factor minus, you get x minus 3. So that should be the problem which you are going to solve or sketch. Do you see that? It makes huge difference. If you are seeing this function, then you may think that 3 is positive and therefore you'll move left. But actually speaking, 3 is negative, you have to move right. Correct? And of course, minus before x, you will be doing reflection, right? And this reflection is on y-axis. So take care of that. Now let me do this one. So what I will do here is, I will do that function, that means I'll sketch the transformed function for a part, which is f of x equals to 1 over 2x plus 4. And I'll expect you to practice with part b, which is now 1 over minus of x minus 3. So now let's try to see how to sketch the function f of x equals to 1 over 2x plus 4. So as I said, this is part A. First thing is factor the coefficient of x, which is 2 in this case. So we'll factor 2 out, and what do we get? We get x plus 2, right? So that is the first step. Now things are very clear. You can treat this 2 as a horizontal compression by a factor of half, and this 2 is horizontal translation 2 units to left, right? Now, especially in case of reciprocal functions, the most important thing is their asymptotes, horizontal and vertical asymptote. Now from this equation, you can get the vertical asymptote by equating denominator to 0. So let's see what is the vertical asymptote. So vertical asymptote is where the denominator is 0. So in this case, it is x plus 2, and this is going to be 0 at x equals to minus 2, right? So vertical asymptote is at x equals to minus 2. So you have to equate the denominator to 0 and find the value of x. That is the way. So we have vertical asymptote of minus 2. How about horizontal asymptote? For finding horizontal asymptote, I will suggest you plug in a big number, let's say 1000 for x, and see what result do you get. So if I write a big number here, I will get 0. 1 divided by a large number will always give me 0. Important thing here to note is whether that 0 is kind of positive or negative. Now that gives us the horizontal asymptote, but also tells us from which side we are approaching 0. Now let's see. If I say I put plus 1000 here, if I put plus 1000 here, then I'll get 0, but it will be positive. Do you get the point? It will be positive. And therefore, I'm going to approach 0 when x is plus infinity towards going infinity from positive side. That means from this side. So that is how I'm going to approach 0. But if I plug in a value which is minus 1000, then this expression will be negative. And well, we are approaching 0, but from the negative side. So in that case, we are approaching from this side. So that is how this is very important. It gives you kind of where exactly the graph lies. We know 1 over x, it is always in 2 quadrants, right? Diagonally opposite. That is kind of thing, right? Now with this, we know these are the 2 quadrants where major part of the graph will lie, right? Now, with this, we can write here, our horizontal asymptote is y equals to 0. See, these are the equations of the lines. Horizontal line, y equals to 0, is x-axis. Now, vertical line, x equals to minus 2. Let's draw this. So this is my vertical line, x equals to minus 2. So draw a dotted line along the vertical asymptote. That demarcates two halves of your reciprocal function. And there is no harm in even showing horizontal asymptote, right? Maybe x-axis, at least you know your function is approaching x-axis. And that is the horizontal asymptote. Now, which are the critical points for this function? The critical points for these functions are when x is equals to 1. That is for 1 over x. But whenever you get a function like this, the critical point is really 1 unit away from vertical asymptote. That is your critical point. So what I'm trying to say is, when you make your table of values and when you're trying to find the critical points, then you should start from 1 unit away from the vertical asymptote. Now here, let's write x equals to minus 2, right in the center. So minus 2, this is my x value, and we'll calculate corresponding y value. When I write minus asymptote, I know this will be vertical asymptote. So we say this is vertical asymptote. So now we are clear. Now the other points which we have to check are actually the points away from minus 2, right? So away from minus 2, so this is minus 2. So if you move towards the right side, it will be minus 1, 0, like this, right? So let's check the value at minus 1. So if I write minus 1 here, what is the value I get? This is what I'm looking for. So substitute minus 1 in your equation and calculate y value. So when you write minus 1, 2 minus 1 is 1, you get 1 over 2, that is half. Right? Now, move further, and next point is, let's say 0. So for 0, it is 1 over 4, right? So we get 1 over 4. Now let's move to the left side of minus 2, which is minus 3. So if I write minus 3 here, minus 3 plus 2 is minus 1. So I get minus half. And minus 4 will give me minus 4 plus 2 is minus 2. So I get minus 1 over 4. So while as expected, it is kind of symmetric about this vertical asymptote, right? So we get these values which are relevant. Now, selecting a scale. If I use a scale 1 unit like this, then truly speaking, half and 1/4 is very difficult to plot, right? So I will try to, well, that is one way. I should have taken a scale which is kind of bigger. But in this particular case, I will take the same scale as 1 unit here, right? So this is my 1 unit, 1 minus, because I've already drawn the vertical asymptote. So I don't want to change my y scale at the moment. So we'll go with this, but my recommendation is that for 1 over x, to get more accuracy and clarity, we should use 2 units as 1, not 1 unit as I'm doing here. So my suggestion is, when you draw it for that function, use 2 units as 1. In that case, you can actually pinpoint where is half, right? And then 1/4 is also not a bad point to plot, correct? In this case, these points are going to be very, very close, right? Now, let's start plotting the points. And we'll always start from here only. So we say minus 2 vertical asymptote, correct. Now let's move right. Minus 1, the value is half. So minus 1, the value is half, which is here. And then 0, 1/4, coming closer. So what we realize is it's actually going very, very close to the graph. And we have to get the values here. So let me take some more values. We are running out of space here. So I'll take some more values in between. I should have entered them right in between, but now let me write here. So when we moved out, let's take minus half. Rather minus 1.5, minus 1.5. So I'll take minus 1.5, and if I plug in minus 1.5 here, then what do I get? I get 0.5 times 2, which is 1. Now let me take minus 0.5. So when you take 0.5, it is 1.5 times 2, so it is so use your calculator to get all these values. That is my suggestion, right? So 1.5 times 2 is 3, so it's 1 over 6. And so we have taken minus 1.5. Minus 1.5 is 1. So minus 1.5 is 1. So we get a point here. So what I'm trying to say is we are approaching closer and closer to this, and so you can draw a graph which will be. Let me sketch it now. Let me use a sketch pen. Since I have taken one unit as this, it is like this. And if you select these points, which is minus 3 is minus half, minus 3 is minus half, and then minus 4 is 1/4, so we are going closer. So that is kind of your horizontal asymptote, right? And if you select these values, you'll find they are symmetric, so they will go like this. So you get a 1 over x, you get kind of 1 over x graph like this, right? Well, as you can appreciate, it is not a very accurate graph. The mistake which I have done here is selecting a unit which was kind of very small to plot all these points, the fractions, right? So when you get values like this, use a better scale. So I will suggest never use 1 unit for 1, right? You can use 2 or 4 for 1 and do a better job out of it. But the thing is that you got the concept how to sketch reciprocal function. So the criteria here is to sketch a reciprocal function. Point number 1 is factor, that is 1, factor the coefficient of x. Second, you should figure out where is vertical asymptote and where is horizontal asymptote. So these are the first lines to be drawn. And then you have to move from the vertical asymptote left and right in the units of 0.5. Then you get all your values, correct? So in the units of 0.5, in this case I moved in the units of 1. So you should have actually moved in the units of 0.5. That means 0.5 increasing on the right side and 0.5 decreasing on the left. So you should have at least 5 points here. And once you have those 5 points with a good scale, you can really make a good graph, right? And also important thing is whenever you're trying to write vertical and horizontal asymptotes, you have to see from where the graph is approaching. So for horizontal asymptote, plug in a big value, a number like 1000, and see whether your expression is positive or negative. If it is positive, you are approaching 0 from positive side. If negative, then you are approaching 0 from the negative side. So that gives you a fairly good idea about how the graph should look like, right? Similarly, for vertical asymptote. So in this case, the vertical asymptote is minus 2. As you see, when you're on the right side of minus 2, you have positive values. So you are approaching this vertical asymptote towards positive infinity from the positive side and towards negative infinity from left of the vertical asymptote. So that kind of defines your reciprocal function, and that should help sketch most of the reciprocal functions for you, right? Thank you.